We can use a solar panel to directly power a load, but it only works when exposed to light. For example, this solar fan will automatically turn on when exposed to light. The brighter the light, the faster it spins. But it doesn't work at night. We therefore need a battery to store the energy. It charges during the day, and we can then use it at night. That's how this very simple battery charger works. However, the voltage and current will vary, and the solar module can overcharge the battery, which will damage it. And at nighttime, the battery can discharge back through the solar panel. So, we separate them using a charge controller. Now, when the sun shines, the controller charges the battery. We can switch the light on, and the controller sends power to the load, with any excess energy going to charge the battery. At nighttime, the controller protects the solar panel from the battery, but it still allows us to use the energy stored in the battery. And that is how these solar-powered phone chargers work. You can see from this simple garden light that inside we have just a solar cell connected to a basic charge controller. This separates the battery and the LED. The solar cell charges the battery, and when charging stops, the light is powered. We can also control the light with the switch. The solar panel and the battery provide DC electricity. If we connect this multimeter to a battery, we see a constant flatline voltage. That's because the electrons are flowing in one direction, much like the flow of water down a river. We can use this to power small DC motors, lights, and USB devices, perfect for motorhomes and boats. But many of our appliances require AC electricity, which works differently. If I connect to this power socket, we have a wave pattern. The electrons are flowing backwards and forwards. It is alternating direction, much like the tide of the sea, flowing in and out. To power these devices, we need an inverter.